Welcome back to our second video on section 1.1. We already talked about factoring in the previous video, but I want to now in this video talk about factoring quadratics where there's some number here in front of the x squared. Okay. That's going to be slightly different than when we were factoring things like last video when we factored this x squared minus 6x plus 8. Namely, the thing that changes is how we're going to set up our product here. Namely, I now need the front terms to multiply to be 2x squared. So I cannot put an x here and an x here like I did last time. I have to instead start with a 2x and an x. Again, think carefully about what you're doing when you factor something. You're really saying at the end of the day, if I FOIL this thing I'm writing down, I'm going to get that. So in particular, I need to have the first pieces here multiply to give me that 2x squared term at the front. So I'll have a 2x and an x. As before, we have these blanks that I need to fit together, and I need to figure out what to fill in these blanks in order to get this minus 9x and this minus 5. Now, one thing that's still true from last time, I still need these two numbers to multiply together to be this n term here, to be this minus 5. The difference is what happens in this middle term. And what's going to happen in the middle term is, remember, these inside terms are going to be multiplied together, and these outside terms are going to be multiplied together. And so what that effect is going to have is that I'm going to have this number plus 2 times this number. That's going to have to add together to be minus 9. Just to say that again, whatever number I have here, it's going to multiply by x, and so I'll get that many x's. But then whatever number I have over here, it's going to get multiplied by 2x, and so I'm going to get twice that many x's. And so, when I'm trying to find the numbers that go in these blanks, I'm looking for a number to put here that when doubled and added to the number I put here gives me minus 9, and where these two numbers multiplied together give me minus 5. What numbers are those? Well, if we do this, I think we want to have a minus 5 here and a plus 1 here. So again, what happened here? 2x times minus 5, that's minus 10x. Plus 1x, that will be minus 9x. And also, the product of plus 1 and minus 5 is minus 5. And this will give me my two solutions, where I again break this up as 2x plus 1 equals 0, and x minus 5 equals 0. Okay, so this will give me 2x is minus 1, which says x is minus a half. And this over here will give me x equals 5. Those are my two solutions to this equation. Now, I want to go ahead and note there's another way you might think of doing this, which is you might also think of using the quadratic formula. And what does the quadratic formula say? The quadratic formula says that if you're looking at the polynomial ax squared plus bx plus c equals 0, then the solutions to this are given by this thing. And so here, if I want to use the quadratic formula, a is 2, b is minus 9, c is minus 5. So I would get x equals, opposite b would be 9, because minus minus 9 is plus 9, plus or minus the square root b squared would be 81 minus 4ac, which will be minus 4 times 2 times minus 5. So that will, in fact, because there's a minus here, that will make this plus 40, all divided by 4. Okay, so that's 9 plus or minus the square root of 121 over 4. Okay, that is 9 plus or minus. Okay, so the square root of 121 is 11 over 4. Okay, and so this is either 20 over 4 or minus 2 over 4. 20 over 4 is 5, or minus 2/4, that's minus a half. Note, this got me exactly the same answers, which is good. I should get the same answers no matter how I do it. I think that usually the quadratic formula is significantly messier. Namely, I had to add some fairly large numbers, and so doing this, especially doing this by hand, is a little bit aggravating. So I would much rather do it this way. But for you, whichever one works, I am happy with. I will note that in the homework packet, all the quadratics that you come across, they will all factor something like this. So if you get something where you would need the quadratic formula, it means that you have made an algebra error of some kind. Okay, I wanted to do just one more example of this kind of factoring. Namely, I wanted to solve the equation 3x squared plus 14x equals minus 8. Now, I'd recommend, if you're new to this kind of equation, you might pause the video here and look ahead and see if you can do this on your own before we do it together. But I'll go ahead and do it now. Okay. So I'll note a lot of people, when they see this, they're inclined to say, I can factor out an x on this side. And this step isn't wrong, but it's not actually helpful. Again, really it's worth remembering, factoring only helps if you have the equation equal to 0. Really what that means is factoring usually has to be your last step, not your first step. Okay, so we're going to cross that out. We're going to back up to 3x squared plus 14x equals minus 8. And I'm going to go ahead and move that minus 8 to the other side so that we can have this thing really authentically equal to 0. So that is, we'll have 3x squared plus 14x plus 8 equals 0. Now, when I go ahead and go to factor this, because there's this 3 here, I'm going to want to break this into something that starts with a 3x and something that starts with an x. Okay. And I again just have to figure out what's going to go in these blanks. Again, I just want to remind you what has to be true. These two numbers have to multiply to be 8, and this one plus 3 times this one must be 14. So these two multiply to be 8, and this one plus 3 times this one has to be 14. It might take a bit for you to think through all the possibilities, but eventually you will come up with the option that works is a plus 4 here and a plus 2 here. Okay. So 2 and 4 multiply to be 8, and 2 plus 12 is 14. That's why this works. So then to finish solving this, we'll take 3x plus 2 equals 0, and we'll solve that, which will give me 3x equals minus 2, so x is minus 2/3. And x plus 4 is 0, so x is minus 4. Okay, so these two, those are our two solutions to this original equation. All right. I'll stop there for now, but I'll see you next time when we'll finish up section 1.1.